Forces and Newton's laws of motion. Mass, it is the quantity of matter contains in it. It is a scalar quantity, it is a SI unit is kilogram. Inertial mass and gravitational mass. The mass of the body which determines its inertia in translatory motion is called its inertial mass. This is the mass that appears in Newton's second law, which can be written as F equals to mi into ai, I for inertial, or mi equals to f by ai. Then this mass is called inertial mass, mi. The mass of a body which determines the gravitational pull due to the earth is called its gravitational mass. This mass appears in Newton's law of gravitation, that is F equals to g mm by r square, or mg equals to f r square by gm. Here this mass is represented by gravitational mass. Inertial and gravitational mass need not to be equal. Inertia is the inherent property of material body by virtue of which it resists in change of a state of rest or of uniform motion. Mass of a body is the measure of its inertia. Inertia of rest, the tendency of a body to remain in its a state of rest is called inertia of rest. Inertia of motion, the tendency of a body to in remain in its state of uniform motion is called inertia of motion. And inertia of direction, the inability of a body to change by itself its direction of motion is called inertia of direction. Now force, which is the physical cause. It is the physical cause which either changes the previous state of the system or body, or has tendency to change it. It is an interaction between two or more objects or systems. It is a vector quantity. Its SI unit is Newton or kilogram meter per second square. Interaction in nature or fundamental forces in nature. At present, we know about four fundamental forces in nature. Gravitational force. It is the force of mutual attraction between the object by virtue of their masses. It is a universal force. It acts over long distances and does not need any intervening medium. It is the biggest force in nature. Second, electromagnetic force. It is the force between the objects due to charge or them. It may be attractive or repulsive. It acts over long distances and does not need any intervening medium. It is very much stronger than gravitational force. The forces, forces, spring, tension, or compression, friction are electromagnetic in nature. Third, the strong nuclear force. The strong nuclear forces bind protons and neutrons in a nucleus. It does not depend on charge and it acts equally between a proton, a neutron and a proton and a neutron. Electron does not experience this force. It acts for very short distance, order of 10 to the power minus 15 meter. Fourth, the weak nuclear force. The weak nuclear force appears only in certain nuclear process, such as beta decay of nucleus. This force is not as weak as gravitational force, but much weaker than a strong nuclear force. Now, on the strength of forces, we can see that strong nuclear force is very greater, then electromagnetic, then weaker, and then the gravity. That is, gravitational force is uh, more a strong force is strongest, and gravitational force is weakest. Each fundamental force is thought to arise from the exchange of its characteristic particles, like gravitational forces arises due to graviton. Similarly, electromagnetic forces arises due to photon, and uh, strong nuclear forces arises due to mesons. And weak nuclear forces arises due to bosons. Now, free body diagram (FBD). It is the diagram showing all forces on a body or a system. Force. Now, force can be categorized in three types, that is field force, attachment, and contact force. And field force, there should be contact between two objects for contact force. That is, contact between two objects is not necessary for a field force. Example: gravitational force, weight, electrostatic force, etc. And attachment, tension, a spring force. There must be attachment between the body, then it will be called attachment force. That is, tension and springs are of this category. And contact force, a contact between surface is necessary. Normal reaction and friction force are of this category. Now, types of force and FPTs. First, let's consider weight. It is the force exerted by earth on any body and always acts in vertically downward direction, that is toward the center of the earth. For example, and it is written by W vector equals to m into g vector, where g is the acceleration due to gravity. Its unit is kg weight, and 1 kg weight is equal to 9.8 Newton. Now, if we take the downward direction as y-axis, then w vector will be mg into minus j cap. On magnitude will be given as w equal to mg, where m is the mass of the body and g is the acceleration due to gravity. Here the different situation is shown. For example, this body is placed on a table, then a vertically downward force is acting on this body, that is weight, and it is given by mg. Similarly, on an inclined plane, mg is vertically downward. In the case of a pulley string system, consider this body, tension is acting on this direction, and but it's here the FPT is drawn. The tension is acting in upward direction, and weight is acting in downward direction. Same case for this body, tension is in upward direction, and weight is in downward direction. Now, tension. This force arises in a string and of pulling behavior. It is always directed away from the experiencing body. If a spring is massless, the tension in it is same everywhere, otherwise different at different points. If a string is massless, the tension in it is same everywhere, otherwise different at different points. Second point, if there is a friction between a spring and pulley, tension is different on two sides of the pulley. Two sides of the pulley. Now, if a string is inextensible, the magnitude of acceleration of any number of masses connected through a string is always same. Different situation is shown here. This is the pulley and this is the string, and two bodies connected, and there is no friction. Then tension will be and string is massless. Then tension will be from here to there will be same. That is as we discussed earlier, that this is of a pulling behavior, and it always away from the body which experiences it. That is, if we consider this body, then tension in a string will be in this direction. If we consider this pulley, then tension will be in this direction. Now similarly, for this, if we consider here pulley, the tension will be in this direction, and if we consider this body, the tension will be in this, that is away from the body, experiencing body. And this is the case for massless string and massless pulley. There is no friction between pulley and string, so all over the string is tension is same. Now the second case, massless string, and massless pulley, but there is a friction between pulley and string. Then in this side will be tension same, and in this side will be tension same, but this side of tension will be different of this side. So here this body is experiencing tension T1, and this pulley is experiencing tension T1 in this direction. But in this side, this pulley is experiencing tension T2 in downward direction, and this body is experiencing tension in a string D2 upward direction. Now the third, massive string and massless pulley. Pulley is massless, but the string is massive. Then this string is massive, that is mass is considered. So tension at every point will be different. That is, for this body tension is T1, for this body, that is pulley, tension is T2, for this T3, and for this body is T4. That is, tension is at every point will be different, because it tension depend on the string of the mass here in this only this situation. Now the massless string. If a string is massless and no friction, and there is no friction between pulley, but pulley is massive, then in this case the tension in this side will be same and this side will be same. So this is the these are situation for calculating tension in a string, and we have to keep this in mind for solving different type of problems. Now our next force is a spring force. The force exerted by a spring on anybody may be of pulling or pushing behavior, and depending upon the situation, and it is a uh, and it is always opposite to the displacement of the body. For mathematically it is given as f vector equal to minus sp. For a spring you cannot write sp, you can only use f vector or fs vector. This is convention, you can only write f vector. So f vector equal to minus kx vector, where x is the displacement in the spring and k is the spring constant. Now Fsp, that is a spring force, equals to kx in magnitude. Here this is the situation is shown when we this is a body connected with a spring. If we pull the spring, then this body will experience a force in this direction due to this spring, and that is the spring force. And it is opposite to the displacement, because body is displacing in this direction, so a spring force is acting in this direction. Similarly, if we pull this force this body in this direction, then a spring force will be in this direction. That is, it always acts opposite to the movement of body. Now about some important point about this proportionality constant K. Uh, about it is known as a spring constant or the a spring rate or stiffness or the force constant. These are names of K. It is defined as the amount of force required to produce unit deformation in the spring, that is F spring equals to Ks when X equals to 1, Fs equals to F Sp equals to K, that is F external C. It depends upon the nature of material of the spring, that is the density and Young's modulus of elasticity. It also depends upon the radius of coils used, the radius of helix, and the pitch length and the active coils. So these are the important point regarding a spring constant. Now the last one is now the next force is contact force, and this in this we have to study two type of force: normal reaction and friction. Contact force: when one body remains in contact with the other, the force related or operating between the surface of contact is called contact force. It is of two types: normal reaction, it is of pushing behavior, it acts between surfaces in contact. For example, a body is placed on the table, then there will be a contact force acting between two bodies. That table will exert a contact force on this body in upward direction, and this force and this body will exert a contact force in on table in downward direction, and both force will be of same type of same magnitude. That is, direction will be opposite, but its magnitude will be same. For example, this body is experiencing contact in this direction and table is contacting